Okay, welcome back to question number 4 in section 6.1 in the topic of finding the area. Here in this question, as we need to find the area of the region bounded by, first of all, we have this standard parabola y equal x squared, and then tangent line to this parabola at the point 1, 1. So I hope you remember tangent line from calculus 1. If not, we will just do a quick reminder of how to find the equation of the tangent line to any function. And finally, also the x-axis. So I think if I go ahead and sketch the region first so that we have an idea of what we are dealing with. So I'll just try to sketch the parabola up here. First of all, the parabola y equal x squared, which is, I'll just do it in the blue color, is the standard parabola with the vertex at 0, 0, and it will go like this and like this. Second, I'll do the tangent line, I'll just do it in red, at the point 1, 1. So imagine this is the point 1, 1. And if we draw a tangent line, should be just a line that touching the parabola only at that point. And finally, the x-axis. So let me go ahead and redo the x-axis with green color here. And that's how we sketch the region. Now, I hope you can see my region. And my region will be this one here. This is the region between the three curves. The parabola y equal x squared, the tangent line, which is in red, and the green line, which is the x-axis. Okay. Now, what we know the blue equation. It is y equal x squared. We know the green line, the x-axis usually is y equal to 0. And what is missing for us is this one, which is y equal to something, which is a line. Let me go to a different page and let's find the tangent line to the parabola at the point 1, 1, find the equation and bring it back here, and then we continue finding the area. Okay. So here we need the tangent line to y equal x squared at the point 1, 1. Now, since it's a line, okay, and we just from the last lesson, we see what's the equation of any line. Any line is y minus y1 equal the slope x minus x1, okay. Luckily, we have x1 and we have y1, so we just go and plug them there. So it will be y minus 1 equal some number x minus 1. Now, in order to find the slope, we have to go back and recall what we know about the slope. So what is the slope of the tangent line? Yeah, it's 2. It is the derivative of the function at that point. Now, what's the derivative? It is y prime or dy by dx. And what's the derivative of y equal x squared? It is just 2x. Unfortunately, we cannot keep it like this because 2x is not a number. What we need is a number. And we need it at the point we are talking about. So how much is the x at that point is 1. So it will be 2 times 1, which is just 2. And that's what I will plug in here. Just quick simplification. It will be y minus 1 equal 2x minus 2. And finally, y will be 2x minus 1. And that's the equation needed to solve the question. So we have the tangent line at any function is given by the standard equation for a line, except that the slope is a special one because it is the derivative of the function at that point. We take the derivative of x squared, we get 2x, and we substitute x equal to 1 because it's already given to be 1, and the answer is 2. You plug it here, you simplify, you get this one. So going back here, my y is equal to 2x minus 1. Now there is a catch here. If you can notice, let me zoom in for you and you can tell me about my region. There is something very weird about my region. Actually, my region is divided into two regions. Can you see them? It's true. I have one region. The top is the blue function. Okay. This is the top. Okay. Until this point here. And then the second one is the yellow one, which is the top is the blue function, but the bottom now is the green. So we have two kind of regions. They split at this point here. So we need to find this point where the red function meets the green function. So let me just do it up here very quickly. The red function is 2x minus 1. It should equal the green function, which is y equal to 0. Now this is very simple equation, 2x equal to 1, so x equal to half. So this point here is 1 over 2. So I have kind of two regions, region 1 plus region 2. And then we need, all what we need to do is we need to find the area for that. So the area, as we just said, it is area 1 plus area 2. In terms of colors, this should be area 1, which is the top is the blue and the bottom is the green. And area 2 is given by this one. So all what we need to do is we need to put a rectangle and we need to find the integration from the top and the bottom. Now, what is the top of my rectangle is the blue function, which is x squared. What is the bottom of my function is the green one, which is just 0. Then if we move my rectangle maximum to the left, I will end up with 0. If I move my rectangle maximum to the right, I will reach this point, which is 1 over 2. So we just go and plug those points, 0 and 1 over 2. Now, for the second region, I think we should do the same. We put our rectangle somewhere in the middle, and we look at the top, and the top is the blue function, which is x squared. And then we look at the bottom, which is the red function. Let me put it between parentheses, minus 1. And the limit of integration, again, if we move my rectangle maximum to the right, I will end up with this point. And remember, this point was a special point. It is 1. So this should be 1 here. Why this is 1? Because this is exactly given in the question, because this is the tangent line at the point 1. And the bottom, if you move your rectangle maximum to the left, it will be up here. Now, this is very easy calculus 1 equation. I would like you to solve it by yourself, and please write me in the comment the final answer so I can check if you did it correctly. I'll just do a quick recap of what we did. As the question was, we need to find the area of the region bounded by the parabola y equal x squared, tangent line to this parabola at 1, 1, and the x-axis. So we sketch those three functions. We sketch y equal x squared. We sketch the line which is tangent at 1. Okay, and we sketch the green line which is the x-axis. All what we knew is that y equal x squared is the parabola, the blue one. The green one is y equal to 0, and now we need to find the tangent line at the point 0, which should be this one. And then we found that it's split into two regions with the intersection at this point. This point is where they differ. So I make the two equations, which is the red and the green, equal to find x equal to half, and that way the region will split into two regions. Thank you so much, and please write down for me any comment, any question in the Microsoft Teams. Thanks.